Good afternoon. This is Charles Lapish, and today I'll be presenting my project management manual, Engineering Project Success in the Nuclear Age. Project management is like operating a nuclear reactor. Both have complex interconnected systems, and success requires precise control and monitoring. Both require strict adherence to safety protocols, and the project manager and reactor operator are both responsible for smooth, efficient, and safe operations while striving for optimal performance. Duke Energy Catawba Project Organization has 64 detailed project management standards and procedures. The Project Management Center of Excellence website, a glossary, project management templates, and subject matter experts. The Project Management Manual and this presentation will provide guidance and recommendations for Duke Energy project managers to manage and improve their own reactors, their projects. Why this manual is needed. Some gaps still exist in the Duke Energy project management framework. This manual will provide practical suggestions, templates, and recommendations for improving the Duke Energy project management processes. This manual will also provide clear guidance to Duke Energy project managers and management on project management knowledge areas and processes. And it will simplify the Duke Energy project management processes for better understanding. And who will benefit from this project management manual? Existing project managers, new project managers, the Catawba Projects Organization, and Duke Energy Management, along with anyone seeking to learn more about the project management processes in general. The project management process groups. There are 5 project management process groups that project managers should use at Duke Energy, and those are the initiating process group, planning process group, executing process group, monitoring and controlling process group, and the closing process group. The initiating process group is the stage where the project is defined, authorized, and started. Like a new reactor build, Duke Energy Management must determine the business case, viability, and alignment of the project with organizational goals. They should also assess the business need, return on investment, strategic fit, social and environmental impacts, and the feasibility of the project. Management also defines the project value, benefits, and strategic alignment. The project charter is developed in this stage where Duke Energy names the project manager and authorizes project expenditures. The planning process group. This is where the project scope is established, objectives are defined, and the course of action needed to attain the objectives. The main output is the project management plan, and this is the reactor core of the project. This project management plan specifies 10 project component plans. On the next slide. Examples include the stakeholder management plan, the integration management plan, and the communications management plan. Here is an overview of the framework for project management and the project management plan. And again, this is considered the reactor core of the project. You have the 10 knowledge areas shown on the right under the project management plan that must be developed by the project manager. The red areas are critical knowledge areas for the nuclear industry. Those include quality management, risk management, and regulatory requirements. And yellow are the high attention knowledge areas in the nuclear industry, and those include managing costs and stakeholder management. The executing process group is where project work is defined in the project management plan and is performed, directed, and managed. The project scope, schedule, and cost are managed per the project management plan and adjusted using change requests and the change control process. Project stakeholders, communications, risks, procurements, knowledge, and resources are all engaged in the executing process group. Here is an overview of the framework for the monitoring and controlling process group. And it starts in the project execution phase, where we monitor project work, perform integrated change control, control the scope, schedule, costs, quality, and resources, monitor communications and risks, and determine whether corrective actions are needed. If they are needed and that decision, then you would implement the corrective actions. And if they're not needed, then you would continue your monitoring and controlling. And the final step is the project completion, next iteration or phase. The closing process group is the delivery of final products, securing final customer acceptance and accepted deliverables, documenting ownership transfer, and establishing customer support and warranty requirements, closing open accounts and finalizing contracts, updating and archiving project documentation, finalizing billing and settling invoices, conducting a post-project review to capture lessons learned and evaluate project performance, developing the final project report, releasing project team members and reallocating company resources, updating stakeholders and organizational process assets, including business case documentation, and ensuring all legal, environmental, technical, and regulatory permits and licenses are properly closed. Here's a picture of a typical nuclear power plant control room and operator. And this, again, correlates also to the project manager who is managing the control room of the project, which is the project management plan. The knowledge areas. Again, there are 10 knowledge areas, and those comprise integration management, communication, costs, procurements, quality, resources, risk, scope, stakeholder, and schedule management plans. Integration management. It's like the control room, which oversees all plant operations. Integration management ensures integration of the entire project management framework. And Duke Energy has a stage gate process, but no integration management process. According to David Wilson, a senior project manager at Duke Energy, integration is left up to each project manager. Duke Energy utilizes some of the integration management processes and outputs, even though they don't have a defined IM plan. And those processes and outputs that Duke Energy uses are the project charter, the project management plan, the project management information system for project knowledge, work performance data and reports, the change control process, and a lessons learned database. Here we see the integration management framework, a typical framework, and it begins with developing the project charter, developing the project management plan, directing and managing project work, monitoring and controlling project work, implementing the integrated change control process, and closing the phase or project. And this leads me to my first recommendation. Duke Energy should establish a formal integration management framework to ensure that project managers integrate the organization's processes, inputs, tools, and outputs across all aspects of the project lifecycle in a consistent, standardized format. Communication management. The reactor operator relies on data channels and alarms in the control room to monitor the reactor condition. Similarly, a Duke Energy project manager must establish a robust project information and communication system to monitor status. This system is established in the communication management plan. Here's an overview of the communication management framework that I've developed, and that includes all the communication models, communication methods, skills, roles and responsibilities, the details of recording a message, a glossary of terms, communication channels, and communication strategies. And this is all in a continuous improvement loop that you review your communication management plan throughout the project, you measure its effectiveness, and then you adjust the plan and implement improvements in order to increase the improvement and utilization of the communication management plan. Communication management takes up 90% of a project manager's time. Duke Energy project managers must manage many different meeting types. The project kickoff meetings, internal technical meetings, project status meetings, high-intensity team meetings, which are also called outage readiness meetings, and external vendor technical meetings. Cost management. The project manager must document cost estimates, determine the project budget, track monthly forecasts of funds, determine project financial performance, and control costs throughout the project life cycle. Types of estimating used are analogous estimating, parametric estimating, three-point estimating, and bottom-up estimating can all be applied. Earned value analysis is used to assess project performance and value engineering principles to maximize project value for a Duke Energy project. Here's an example of some earned value formulas that Duke Energy utilizes in tracking the performance of their projects. And these are standard earned value formulas that you'll also see within the PMBOK and the Department of Energy earned value management standards. These include the budget at completion, the plan value, the earned value, the actual cost, cost and schedule variances, the schedule performance index, the cost performance index, the estimate at completion, the estimate to completion, variance at completion, and to complete performance index are all calculated in a Duke Energy project. Note that for variances, a target of 0 indicates a positive result, while a positive value is considered good and a negative value is considered bad. For schedule performance index and cost performance index, the target is 1. A value greater than 1 is good, while a value less than 1 is bad. Procurement management. Duke Energy project managers must develop a procurement management plan, conduct and control procurements. The procurement management plan specifies procurement strategy, make or buy decisions, the bid process, scopes of work, vendor selection, contract types, claims, and change requests. Also, the PMP specifies how to evaluate work and vendor performance, inspections, and audits. Duke Energy contract framework and training are really intense. Multiple standards, procedures, and classroom training are required for new project managers. Here's an overview of the procurement management framework. You want to identify your procurement needs as a project manager, plan your procurements, prepare procurement documents, conduct your actual procurements, control those procurements, and then close those procurements at the end of the project. This leads me to my recommendation number 2. Duke Energy should streamline and simplify the procurement and contract management training for new project managers. Doing so would promote consistency across projects while reducing the administrative workload for project managers and support staff. Quality management. Quality standards and procedures ensure optimal performance, meeting stakeholder expectations, and support continuous improvement. Quality management covers many standards and methodologies, such as TQM, Kaizen, ISO 9000, Six Sigma, and Three Sigma. And within the nuclear industry, there's a couple different nuclear-specific standards, such as ASME NQA1 and NRC's 10 CFR 50 Appendix B. Here's the typical quality process that Duke Energy project managers must follow. They identify quality requirements, they perform quality assurance, and they perform quality control, and this is only for safety-related projects at Duke Energy. This process provides the framework for monitoring, controlling, and improving quality throughout the project lifecycle for safety-related equipment and components only. A key component of the quality process is data collection, analysis, and interpretation to verify quality. Several analytical and graphical tools are employed to support these activities, including cause and effect diagrams, control charts, Pareto charts and histograms, run charts, scatter diagrams and flow charts, and probability distribution curves. And this leads me to my third recommendation. Duke Energy should expand the involvement of the quality department in collaboration with the Catawba Projects Organization, particularly for non-safety related projects. Strengthening this partnership would ensure that non-safety related project activities, processes, and deliverables consistently align with defined quality standards and customer expectations, while also promoting continuous process improvement across all projects. Resource management. Resource management is essential for effectively planning, estimating, acquiring, developing, managing, and controlling resources, including personnel, equipment, materials, and supplies. At Duke Energy, resource management is a process of managing resources to successfully execute and monitor a project according to the resource management standard. The Duke Energy resource management process contains two process steps: planning organizational resources and identifying project manager and confirming organizational readiness. Resource management at Duke Energy, the project managers use the following tools and outputs: the resource management plan, the resource breakdown structure, a responsibility assignment matrix, a RACI chart, which indicates the responsibility, accountability, consulting, and informing requirements for each of the groups, the team charter, parametric, analogous, and bottom-up estimating, virtual, co-located, and on-site teams, team performance assessments, and work performance information. Here's an example of the resource breakdown structure for a typical home construction project. And you'll notice the WBS structure on the left, starting with personnel, materials, documentation, fees, and equipment. There's 3 levels to the WBS, and this resource breakdown structure also includes the units of measure in column 2, the quantity available, and the cost and price of the resources. And those resources include personnel, again, materials, documents, fees, and equipment. And this template can be used by Duke Energy project managers in developing their own resource breakdown structure. Here's an example of a RACI chart that I developed that project managers can use to identify, again, the responsibility, accountability, consult, and inform requirements on the project for various groups. Risk management. Nuclear plants must proactively mitigate risks related to containment breaches, core meltdowns, and emergency events. Similarly, for the Duke Energy project manager, risks must be carefully planned for, identified, analyzed, and addressed through appropriate response strategies and mitigation actions. The Duke Energy risk management process comprises 3 steps: identifying the risk, assessing the risk probability and impact assessment, and responding to risks with a risk handling strategy. Here's an example of the risk handling strategies for various types of positive and negative risks. For negative risks or threats, we can avoid, accept, mitigate, or transfer the risk. For positive risks or opportunities, you can enhance, ignore, exploit, or share the risk. Some best practices for developing risks in your risk register include being specific by using short risk names and descriptions, using if-then statements with one condition and one consequence, assigning the risk owner in accordance with the RACI chart, only if responsible or accountable, adjusting risk probabilities throughout the project as conditions change, being careful to use accept as a mitigation strategy only when the cost to mitigate is prohibitive or poses so little risk the investment to mitigate is not viable, and evaluating the cost to mitigate risk in accordance with the cost of risk impact and probability. Recommendation number 4. Duke Energy should ensure that the risk register is consistently updated throughout the project lifecycle. Although current risk management procedures require regular updates, this practice is not consistently followed by project managers in their execution. Scope management. Just as a reactor core requires a precise, well-defined design, a Duke Energy project must have a clearly defined scope managed through a comprehensive scope management plan. Scope management plan clarifies how the project scope will be defined, confirmed, and controlled, and is a component of the project management plan. The scope baseline includes the work breakdown structure, the work breakdown dictionary, the project scope statement, and all approved changes. Here's a scope management framework that Duke Energy project managers can follow for planning scope management, collecting requirements, defining the scope, creating the work breakdown structure, validating the scope with the customer, and controlling the scope. Here's an example of engineering work breakdown structure, or WBS. It has 3 levels, and it has the work packages at the bottom level, which can be assigned, scheduled, cost assigned to them, and work performed. Scope management. Project managers use the validate scope process for formalizing acceptance of the completed project deliverables through inspection and decision making. The project deliverables must be formally accepted and approved by the customer and meet requirements as specified in the requirements and project scope documents. The project manager must update project documents such as the lessons learned register, requirements document, traceability matrix upon completing the scope management process. Stakeholder management. Stakeholder management is used to identify stakeholders, plan, manage, and monitor their engagement. Stakeholders must be identified, analyzed, and actively managed via the stakeholder register to assess and influence their impact on the project's success. Primary stakeholders have a direct impact on the project and can be internal employees, managers, or shareholders. External stakeholders can be customers, suppliers, investors, or regulatory bodies. Stakeholders can have a positive or negative influence on the project. Here's an example of the stakeholder power interest matrix. Stakeholders are assigned different levels of interest and influence or power on this matrix, with the key players with the highest interest and the highest influence or power shown in red on the top right. Again, you want to categorize each of your stakeholders according to this matrix and assign them their location on this matrix. And then by doing that, you'll know how you should interact and communicate with each stakeholder. For example, the engagement strategy for stakeholders, if they have high power and high interest, you should manage them closely through weekly face-to-face meetings and executive briefings. If they have high power and low interest, you should keep them satisfied through executive summaries and quarterly reports. For stakeholders who have low power but high interest, keep them informed via quarterly newsletters, town halls, and surveys. And for those stakeholders with low power and low interest, monitor them by the annual reports, website updates, and utilizing social media. Recommendation number 5. Duke Energy should adopt an agile approach to stakeholder communication, enabling more frequent feedback loops and improving collaboration throughout the project lifecycle. This approach would help ensure that final deliverables align with customer expectations and support more adaptive, responsive project execution. Schedule management. Every nuclear reactor operates under detailed schedules for maintenance, refueling outages, and online work activities. Similarly, a Duke Energy project manager must develop a detailed schedule management plan. The plan should specify how to define and sequence project activities, estimate activity durations, develop the project schedule, and control the schedule. Here's an example of a schedule management framework, which begins with planning the schedule management, defining the schedule activities, sequencing the schedule activities, estimating those activity durations, developing the actual project schedule, and controlling the schedule. Duke Energy project managers should be familiar with the following schedule-related activities: decomposing the project work breakdown structure into work packages, determining activity relationships, float, free float, leads, and lags, utilizing estimating techniques such as analogous, parametric, and bottom-up estimating for estimating effort, durations, and costs, utilizing the critical path method to calculate a schedule's critical path, determining resource optimization levels for available project resources, compressing and fast-tracking a project schedule, and leveraging other schedule reporting tools such as Gantt charts, baseline schedules, and milestone schedules. Here's an example of an IT project schedule I developed in Gantt chart format for this project management manual. Notice again the WBS structure on the left-hand side, and throughout the schedule, columns 1, 2, and 3. The work packages assigned in column 3, the assigned organization, column 4, the percent complete, the start and end dates, and the duration with the bar graph on the right-hand side. Here's a picture of a nuclear fuel assembly being tested by some technicians. Progressive project management practices at Duke Energy. Duke Energy incorporates the following progressive practices in the Catawba project organization. Risk-informed ranking of projects, where they categorize projects according to financial risk, schedule risk, degree of difficulty, external impacts, stakeholder complexity, and contracting strategy risk. Another type of progressive practice is adding quality, value, and risk to the triple constraint diagram of scope, cost, and time. And finally, adding knowledge areas for claims management, earned value management, environmental health and safety management, and lessons learned management. And this brings me to my final recommendation. Duke Energy should formalize lessons learned and knowledge transfer requirements by adding a standard process for capturing lessons learned at key milestones, developing a lessons learned repository, holding biannual project organization reviews to identify trends, and developing a top 10 recurring issues list for projects over time. This would prevent repeated mistakes and build organizational knowledge. I want to thank you today for listening to my presentation. And if you have any questions or comments, please forward them to me. Thank you very much.